What you are about to watch is a new media assignment in partial fulfillment of the module SP1202 in the National University of Singapore and might potentially blow your mind. Physics has provided a lot of answers to our questions over the years, but with all of its success, there are still a few problems in physics that even after a century of research, physicists are still no closer to solving. The first of these is the nature of fundamental constants. Values that are eternal and unchanging since the birth of the universe. But as of now, we just do not know how these values are determined. The second and even bigger problem is called the marriage problem, whereby two of the most revolutionary theories in physics, quantum mechanics and general relativity, are clearly and distinctly incompatible with each other. This has been called by some as the biggest problem in physics. However, recent developments show that there could be a solution. Do you want to know what it is?
You take the blue pill. The story ends. You wake up in your bed and believe whatever you want to believe. You take the red pill. You stay in Wonderland. And I show you how deep the rabbit hole goes.
So you have taken the red pill. Now, let me introduce you to the multiverse. The multiverse that's able to solve these problems is called the string landscape multiverse, and it is born from two theories, the string theory and the inflationary model of the universe. Both of them combine to give you the string landscape multiverse. For string theory, it reimagines the point-like particles into vibrating strings with a definite length. String theory also states that our universe not only consists of the usual three-dimensional space that we see in our everyday lives, but also a six-dimensional space that we cannot observe called the Calabi-Yau shape. In the 1970s, there were less than 10 such known Calabi-Yau shapes, but today we have recorded up to 10 to the power of 500 of such shapes. The inflationary model is a widely accepted notion that in the beginnings of the universe, there was a period whereby the universe underwent super fast inflation before it cooled to the slower rates we know today. By combining the two, we find that if inflation only cooled down in our region of the universe, it can continue elsewhere while also cooling down in different separate regions. We would then obtain many different bubble universes that have different Calabi-Yau shapes, and our universe would resemble something like a Swiss cheese. This is the string landscape multiverse. We now consider how the multiverse theory solves the problems that we had. Firstly, for all the efforts in solving the marriage problem between quantum mechanics and general relativity, the one that has come closest is string theory. We finally see that quantum mechanics and general relativity are compatible. Such a brilliant theoretical breakthrough gives a lot of credibility to string theory and its extension of the multiverse. For the problem of the fundamental constants, we see that it's also readily solved by the multiverse. We find that the how particles are moved in the Calabi-Yau shapes actually determines the fundamental constants that it has. So, if there were many different bubble universes, each with a different Calabi-Yau shape, our specific value of fundamental constants in our universe is no longer an unexplained mystery, but instead merely a statistical probability. However, the multiverse is a controversial development unlike any theory before it. Direct observation of the multiverse very likely can never be achieved. As physics is a discipline grounded on empirical science, the multiverse simply cannot satisfy these requirements adequately. Can it still be counted as a science? There are also other theories in physics that can potentially solve these problems. So, if we decide to accept the multiverse without strong empirical backing, we might be stagnating the very pursuit of truth that is the principal goal of science. So, with such controversy surrounding the multiverse, in order to get a better understanding on this issue, we have managed to contact one of the world's leading physicists for his thoughts on the matter.
While I subscribe to the many worlds theory, which posits the existence of an infinite number of Sheldons and an infinite number of universes, I assure you that none of them am I dancing.
For me personally, despite all of the dangers that accepting the multiverse could cause, I feel that ignoring the multiverse would be an equally if not more dangerous decision. The strong explanatory framework and theories that the multiverse provides is simply too much of a coincidence to ignore, and not to consider it in the pursuit of truth would be the real prejudice against science. My name is Daryl Lim, and you have just watched my presentation for SP1202, and I hope you have enjoyed it. Thank you.